We need to verify the alignment on section 7 before the next phase.
Copy that. Running diagnostics now.
Check the tolerances on this section here. The welding seems slightly off.
Let me see. Rerun the diagnostics on the robotic arm.
According to the digital twin, this panel should align perfectly.
The laser alignment shows a slight deviation on the starboard side.
Checkpoint clear. Proceed to intake.
Verify alignment on the starboard side. We can't proceed with the weld until the tolerances are met.
Check the alignment sequence on the starboard stabilizer.
Running diagnostics now. Stand by.
Monitor the temperature spike on the forward seam.
Reading stable at 500 Kelvin. Continuing the sequence.
We need to verify the alignment on the starboard side before the next phase.
The robotic arm is calibrated for the adjustment now.
We need to verify the alignment on section 7.
The telemetry data on the tablet shows a minor deviation right here.
We need to verify the alignment before the weld sequence begins.
The robotic arm is compensating for the microfractures now.
The thermal signature on section gamma is still too high.
We need to adjust the coating sequence.
The alignment sequence shows a deviation of 0.02.
Understood. Adjusting the gantry coordinates now.
Check the alignment on section 3. The starboard rail calibration seems slightly off.
Copy that. Adjusting the parameters now before the next sequence begins.
Check the riveting sequence right here. It looks slightly off spec.
I'll have the automated system verify the depth measurements immediately.
The alignment on the starboard fuselage looks precise.
Confirmed. The robotic arm is cleared for the next sequence.
The tolerances on section gamma are tighter than the initial specs.
The arm is calibrated for the update, and we just ran the diagnostic. We're maintaining a 5-micron precision on the leading edge cut.
The AI-driven alignment is definitely improving the yield.
Monitor the torque on the central sequence. We're seeing minor fluctuations.
It's within the acceptable margin, but I'll flag it for review.
Check sector gamma 12. The sensor array shows a possible density fluctuation.
Copy that. Moving the probe to the specified coordinates.
The localized heating right here seems high.
Let me rescan that section. Okay, the signature matches the baseline now. We're good to proceed.
This classified facility represents the pinnacle of aerospace engineering, focusing on the critical radar-absorbent material.
Ensure the ram coating is completely uniform here.
Yes, calibrating the scanner now.
Check the torque specifications on the leading edge. The robotics report a slight deviation.
Running the scan now. It looks within tolerance, but let's rerun the diagnostic.
We need to verify the alignment on the schematic before the next riveting sequence starts.
The stress analysis on this bulkhead requires the new composite layup.
All right, I'll adjust the parameters for the next sequence.
We are approaching maximum compression on the spar.
Data looks good. Proceeding as planned.
The starboard measurements are holding steady at 99.8% accuracy.
Good. Let's verify the ram coating alignment on the next pass.
Rerunning the measurement on the fuselage curvature now. The data stream shows a minor variance here.
Understood. Let's cross-reference with the CAD model before proceeding.
The laser scan shows a microfracture on the fuselage near the intake.
Confirmed. Rerouting the schematic for revision.
Here in the main bay, the specialized cooling of the composite materials is critical for structural integrity and performance.
The cryogenic mist ensures the structural integrity of the composite layers during the high-speed curing process.
We're seeing unexpected fluctuation at 90% load.
The strain gauges confirm the anomaly. We are holding steady.
Target load approaching critical on the starboard wing. Ramp rate holding steady. Pressures are nominal.
Check the tolerance on this section here. The thermal scan is showing a slight deviation.
Copy that. Adjusting the flow rate now.
The alignment on the starboard wing box is showing a deviation of 0.02.
Adjusting the gantry feed rate now. We should compensate.
Check the tolerances on section 7. The automated arm is showing a slight deviation.
It looks within parameters on the main schematic. Let me cross-reference the build data.
The sensor calibration on the vertical stabilizer is still reading high.
Rerunning the diagnostic sequence now. Let's see if the alignment shifted.
Here at the classified Skunk Works facility, the future of air superiority is taking shape at an unprecedented pace.
Control, this is Transport Lead. We are approaching Sector 4.
Confirmed. Transport Lead. Clear access at Bay 7.
Deceleration command received. Holding pattern initiated.
Copy that, Alpha. Secure the payload. We are good to proceed with the next phase. The scan on the rotor assembly is complete.
Alignment looks good across all parameters.
The thermal readings on Array 7 are still fluctuating outside tolerance.
Confirmed. The sensor output is erratic. I'll flag it for recalibration. Check the thermal coating on the 7th blade down. We had an anomaly in the last test run. The laser scan shows a minor irregularity, consistent with the telemetry.
Alignment at Sector 4 nominal. Proceed with lowering sequence.
Roger that. Engaging hydraulics, descent initiating.
Check the tolerances on Sector 4.
Reading stable at 0.002, green.
Looks good, lock it down.
Check the primary seal integrity.
Reading confirmed. We are good for the next phase.
Check the thermal gradient on Sector Gamma.
Looks nominal. The laser calibration is holding steady.
Proceed with the final weld sequence.
We need to adjust the alignment on Sector Gamma 12.
Copy that. Rerunning the calibration sequence now.
Did you verify the thickness on the schematic?
Yes, it's within tolerance.
Okay, logging the sign-off now.
Test sequence complete. Vibration stabilizing.
Acknowledged. Data acquisition successful. The sensor readings on casing 5 are fluctuating outside the acceptable parameters.
I see that. Let's recalibrate the input against the baseline data now.
Ensure the torque is exactly 75 Newton meters.
Confirmed. Sensor suite is green.
This diagnostic tool will highlight any heat discrepancies in the manifold.
Understood. Let's run the sequence now.
We need to verify these serial numbers against the manifest.
Okay, I'm showing B27Q9 at this station.
Look at the vortex stability here, right on target.
Confirmed. The adjustments worked perfectly.
Check the pressure reading on manifold 7. We're showing a slight variance.
Confirmed. Adjusting the parameters now. Looks stable.
Good. Final clearance for pre-ignition sequence.
Sequence initiated. Pressure stable.
Copy that. We have ignition and sustained burn at 20%.
Affirmative. Data looks good.
Monitor the thermal load on section Gamma.
RPC values are stable. Structural integrity confirmed.
The thermal mapping on the rear stabilizer looks anomalous.
Rerunning the diagnostics now. It seems to be holding steady according to the physical sensors.
Engine stabilized. Shutdown complete.
Confirming green status with the tower. Engine shutdown complete. Parameters nominal. Confirmed. Logging data.
The torque setting is correct according to the schematic.
Confirmed. Secure the main harness.
Pin alignment looks good on the main avionics bus.
All right, secure the clamp and log the installation sequence.
We need to verify the connection points for the EW system on the Pylon 5 interface.
Okay, let's cross-reference the build sheet, make sure the gauge is correct before we secure it.
We need to ensure the alignment is perfect before initiating the sequence.
Confirmed. The tolerances are extremely tight on this module.
We need to adjust the alignment tolerance on section Gamma 12.
Confirmed. The robotics will compensate automatically after the update.
Test sequence finished. Readings look good.
Agreed. Secure the unit.
Alignment is steady at 0.4. Copy that.
Proceeding with the securing sequence now.
Alignment looks good. Lock the sequence.
Confirmed. Running level 3 diagnostics now.
Data stream complete. All parameters verified. We are green for flight systems check.
The tolerance levels on the starboard stabilizer are still showing red.
I see that. Cross-reference with the stress test data from Sector 4.
We need to verify the alignment specs before the next phase of welding.
The secure terminal data confirms alignment is within parameters.
Run the alignment sequence for Sector Gamma. Check IRU stabilization immediately after lock.
Sequence running. Stabilization holding at 99%.
The inertial platform alignment is holding steady at 0.02 degrees.
Confirming telemetry synchronization.
Cross-reference with the encrypted GPS feed.
Check 1, backup systems engage.
Engaging backup systems now.
Confirmation, all indicators green.
Good job.
Switching to backup hydraulic pressure now.
Confirmation on System B, all green.
Good. Close out the ticket.
Main avionics online, bus power steady.
Confirmed. Telemetry is green. Proceed with systems check.
Test sequence 4-7 complete.
Copy that. Latency is stable across all parameters.
Good read.
Test sequence complete. All green on my side.
Confirmed. Data logs match specifications. The luminance uniformity looks good on the main MFD.
Confirmed. Checking for NVIS gain variations now.
Ensure the standby instruments are fully compliant.
All right, running NVC sequence 1. Confirm green spectrum at 75%.
Confirmed. Spectrum holds steady. Moving to infrared check.
Module seated and locked.
Verifying secure connection. Status reads green.
Running the sweep on auxiliary frequencies. How's the antenna response?
Solid reception across the band.
Confirmed. All systems nominal. We have a pass.
Rerunning the sensor calibration sequence on port 4.
Acknowledged. We are showing green across the board now.
We have stabilization on the primary indicators. The fluid systems are nominal.
Acknowledged. Uploading the report now.
The sensor array is flagging a deviation right here.
Confirmed. The signature on the leading edge is inconsistent.
Reroute the diagnostic sequence immediately.
Initiating Sector 4 scan.
Data stream looks nominal. No subsurface anomalies detected.
The reset is complete. Check the diagnostics on the main assembly arm.
Looks good. Stabilization is within tolerance.
System reset confirmation.
All systems check green on the avionics suite, Colonel. Test parameters are nominal.
Confirmed. Seal her up, Lieutenant. We are good for integration.
Gantry team, you are clear for final ingress. Hold speed at 0.5 meters per second.
Copy that lead. Entering the chamber now. Confirming trajectory alignment. Move sequence initiated.
Acknowledged. Clear to proceed to Chamber 5.
The precision surface cleaning is critical for radar-absorbent material application.
The laser trace looks clean on the dorsal stabilizer.
Confirmed. We are clear for sealant application on Sector 7.
Ensure the pressure holds at 40 psi for the next section.
Copy that. Maintaining consistent flow.
The robotic gantry applies the radar absorbent material, or RAM coating, a critical step for stealth capabilities.
This robotic system ensures the stealth coating is applied flawlessly, critical for the aircraft's low observable signature.
The RZ-12 coating is adhering perfectly to the starboard wing.
Acknowledged. We are maintaining optimal pressure and temperature alignment.
The AGV path needs adjustment before the next sequence.
Already signal control. We have clearance for the manual alignment.
The stress analysis on Section 7 looks marginal.
We need to reinforce the composite layering there before the next phase.
The temperature gradient is stabilizing perfectly across the fuselage.
Acknowledged. We are clear to begin retraction sequence on the bay doors.
Heat variance is within tolerance.
Confirmed. The coating should be fully cured by 0800. Are the REM layers, BRAM layers bonding correctly at this temperature?
Yes, the robotic arm is maintaining the precise...
The trailing edge return is slightly higher than simulated here.
Yes, but still well within the acceptable RCS margin for this frequency.
The radar cross-section looks nominal here.
Confirmed. The trailing edge data matches the projection.
Check the airflow on section 4. I'm showing a discrepancy.
According to the schematic, this tolerance needs adjustment before the next phase.
I agree. Let's recalibrate the arm before proceeding.
Check the alignment on section 7. The tolerances are tight.
Reading green across the board. The laser calibrated perfectly this time.
Serial number confirmed and logged.
Check the alignment on the starboard stabilizer.
Reading 99.8, engineer. Holding position.
Check the alignment on this panel seam again.
Confirmed. The data shows it's within tolerance now.
All right, finalize the report.
Alignment is within tolerance. Proceed with the automated sequence.
Sequence initiated.
Torque wrench engaging now.
Initiating pressure sequence now.
Confirming full extension. Check the seals.
Reading stable, looks good. Sequence complete. The starboard aileron test is complete. Move to the taileron sequence.
Copy that. Initiating sweep.
Initiating pressure sequence on main gear.
Pressure holding steady at nominal levels. Acknowledged.
Cycle complete. Disengaging hydraulics.
Forward hinges secured. Digital readout confirms torque specifications met.
Confirmed. Gantry, retract to home position. We'll initiate final inspection sequence alpha.
We have a perfect seal across the lower quadrant. No pressure leakage detected.
Good. The thermal signature looks consistent as well.
Full system diagnostic shows all systems nominal.
Confirmed. The aircraft is ready for the next phase.
Systems check is green across the board. Canopy secured, ready for spool up.
All systems green, proceeding to checkpoint 4.
Copy that. Gantry clear overhead. This is test control. Initiate emergency power sequence.
Acknowledged. We have canopy closed and locked. All systems nominal.
The pressure verification is complete. All metrics are nominal.
Understood. Disconnecting the line now.
This facility represents the pinnacle of aerospace engineering, integrating advanced robotics with human expertise.
Clear the bay doors. We are moving to the threshold.
Doors are cycling now, engineer. Proceed.
All systems are green for rollout. Maintain current vector. We are clear for taxi.
According to the Drawstick's readout, the hydraulics on the starboard landing gear are fully calibrated.
Confirmed. The tolerances on the starboard gear are within spec, Commander. We ran the diagnostic sequence twice.
All right, looks solid. Let's move on.
The readings on the tablet confirm optimal performance here, Captain.
Understood. But I still want a closer look at that actuator linkage before sign-off.
Hold. Stand by for systems check.
Okay, all clear. You are good to go.
We are seeing significant heat distortion past the convergence zone.
The tolerances are holding, but let's monitor the telemetry closely.
Tau team, clear to proceed. Aisle 4 remains secure. Roger that. Maintaining 2 knots. All systems green.
Check the tolerances on the starboard side fuselage panel.
Looks good, right within spec.
Ensure the tolerances here match the revised schematics on the tablet. We can't afford any deviation on the stealth coating.
Verify the alignment on the starboard wing section.
The laser scan shows a deviation of 0.05 millimeters.